Hey coders, welcome to our channel. This is our day 1 of solving DSA question series and help you improve your programming skills. In today's video, we will be discussing how to find the next largest element for each element in the array. If there is no larger element, then replace it with the minus 1. Let's consider an array and with n is equals to 6. So let's understand our question with this example. For the first element 1, the next largest element is 23. For the second element 23, there is no larger element in the array, so it will be replaced with the minus 1 in the output array. For the first element 1 will be 23, and for the 23 it will be minus 1. For the third element 5, there are two larger elements 7 and 8. Since 7 is the nearest element, we will consider it as the next largest element. Similarly, for the fourth and fifth element, that is 7 and 8, the next largest element are 8 and minus 1 respectively. So for the 5 is 7, for 7 and 8 will be 8 minus 1. So finally, for the sixth element, there is no larger element in the array after that, so it is replaced with the minus 1. Now come to the solution. First we will solve with the brute force algorithm. Let me just copy and paste the brute force code. I have already done it. The idea behind this algorithm is to loop through each element of the array and find the largest element to its right. To do this, we use a nested for loop. This is the nested for loop. The outer loop iterates through the each element in the array, and the inner loop iterates through the element to the right of the current element. If we find a larger element, we add it to the output array and move on to the next element. If we don't find a larger element, we add minus 1 to the output array. I hope you understand this. That's it for the brute force code. I will not take too much time on it. If you have any query regarding this, then you can ask me. But the problem with this algorithm is that the time complexity of this algorithm is O(n) square, since we are iterating through the array n times and comparing each element to the element on its rise. This can be efficient for larger array, but we are not going to go with this algorithm. As we are coders, we need something better than this. So I will just remove it. I will not remove it. Now the time for the better algorithm. To solve this problem, we will use a stack data structure to find the next largest element. I have already created the stack class. Let me copy that. Paste it. We will start iterating the array from the right to left. So this is our array. From right to left, that is 2, 8, 7, then 5, and then 23, and then 1, and push the element into the stack. Let's if you don't know about the stack, then go to my Medium page. I will put it in the link in the description. I will just give a brief about the stack here. So stack is basically like a stack of chairs, like you can see here. Tell me one thing, if you want to put or take a chair from this stack, How will you do that? You would say if I want to take chair, I will take it from the top. And similarly, if I want to put a chair, I will put on the top. This follows the LIFO rule. LIFO means last in, first out. So in a stack, whatever the last element you have put will become the top element, and top element will always be the first to remove or taken out. So in this case, top chair will be the first to taken out. I hope this is clear to you. We basically use push and pop function in the stack. And there is another function peak. Peak is just the last element of the stack. So peak is the top element of the stack. It gives us top element of the stack. If you don't understand it, then go to my page. I have already described it there. We will start from the last element of the array. For each element, we will compare it with the top element of the stack. There will be three conditions. So first time, so initially our stack will be empty. So let's start with the 2. Initially the stack is empty, which means there is no element to the right of the 2. 2 is the rightmost element. We will push the current element 2 to the stack and minus 1 to the output array. Let me write down conditions. Condition 1. When stack is empty, push stack and install. Okay. Now to the next element 8. If the top element of the stack, that is 2, is smaller than the current element is 8. So 2 is smaller than 8. Then we will replace it with the current element. Replace it with the current element. Don't worry, I will explain it later why we are doing this. I will explain this condition more in detail with 23 as our current element. So now focus on condition 2. If the top element of the stack, which is 8, right, greater than the current element, let's take current element as 7. So if the top element of the stack, which is 8, is greater than the current element 7, then we will add the top element of the stack to the output array and push the current element to the stack. When and add the top element of the stack to the output array. First we will do this, then now comes to the condition 3. So In condition 2, if we keep doing this till 5, we will have stack 8, then 7, and 5. So now our 5 will be on the top of the stack, and below that 7, and after that 5. Sorry, 8. If the top element of the stack, that is 5, is smaller than the current element, which is 23, then we will pop the element from the stack and keep popping the element until we find an element that is larger than the current element, larger than 23 in this case. If there is no larger element, we will push -1 to the output array. 1 top element of the stack is smaller element the element until we found larger element of stack. Alright. Let me explain once more. In starting, our stack is empty. Let's take a stack as empty. There is no element in the stack. So our current stage is this array, stack, and output. Right. We'll start from the last element, that is 2. For the last element 2, the stack is empty. So it push -1 to the output array and push 2 to the stack. The output array becomes -1. The stack becomes 2. So our stage is changed to this. That is the first way. For the second last element in the input array, since it is larger than the top element of the stack, it is larger than the 2. We can replace 2 with 8 in the stack. This is because 8 will become the next largest element for the elements to the left of it. So we don't need to keep 2 in the stack anymore. After replacing 2 with 8 in the stack, we push -1 to the output array. Since there are no larger element to the right of 8 in the input array, so the output array becomes -1 -1 and the stack becomes 8. So our next stage is this. For the third last element, 7, it is smaller than the top element of the stack. Right? It is satisfying the second condition. When top element of the stack is greater than current element, add the top element of the stack to the output array and push the current element to the stack. So it push 8 to the output array and push 7 to the stack. The output array and the stack becomes -1 -1 8 and stack becomes 8 7. So here 7 will be the top most element of the stack and after that 8. So for the fourth last element 5, it is smaller than the top element of the stack, that is 7. It will go to our second condition again. So it push 7 to the output array and push 5 to the stack. For the fifth last element 23, The algorithm enters the third condition. Because 23 is larger than the top element of stack, that is 5. It then keeps popping element from the stack until it finds a number that is larger than 23, or until the stack is empty. In this case, first it will check the current element 23 is larger than the stack top 5, so it will pop 5. As now 5 is popped out, our next top element in stack is 7. Again, it will check whether the current element 23 is larger than stack top 7. As it is not, it will pop 7. Similarly with the 8. Once it ends, it will check if the stack is empty. As now stack is empty, it push -1 to the output array and push 23 to the stack. So now result is this. For the first element 1, it is smaller than the top element of the uh, top element of the stack. So it pushed 23 to the output array and push 1 to the stack as per second condition. I hope you understand. We have talked enough. Let's go. Let's initialize a stack and create a function that takes array as an input. First we initialize an empty array output to store the result. Use creating function. So this output will store our result. Next we iterate over the array in a reverse order using a for loop, as we have to go backward. This loop will go from the last element of the input array to the first. So let's create that. There are three conditions that we will check in this algorithm. The first condition is when the stack is empty. In this case, we push -1 onto the output array and current element to the stack. The stack is empty. The second condition is when the current element when the top element of the stack is greater than the current element, then what we'll do, we will add the top element of the stack to the output array and push the current element to the stack. So I'll say then we will the third condition was true to the case where the current element in the array, the top element of the stack is smaller than the current element of the element until you find larger element or empty stack. and array is equals to stack. We have to use while loop here, and we will keep popping out the element, right? So once the while loop terminates, we check if the stack is empty. If it is empty, we push -1 to the output array because there are no elements in the stack that are larger than the current element. Otherwise, we push the top element of the stack to the output array because it is the next largest element to the current element. Finally, we push the current element to the stack. Is if stack dot is empty, then we will push the -1 to the output. Else, we will push the stack top. And last, we will push the current element in the stack. Let's print this. It's not defined. My bad. Also, I need to comment down the things. Right? Let's run it. Okay, so we are not returning anything. Right? We have to return it as well. You will see that the result is inverse what we were thinking of getting, right? Because we are taking the element from the right to left, so we need to reverse our result. For this, we will use the reverse inbuilt function of JavaScript, and there you go. So we got our answer. Thank you guys for watching this video. I hope you enjoyed it and found it very informative. Don't forget to like and subscribe to my channel for more videos like this one. If you have any question or comments, feel free to leave them below. Until next time, keep learning.